There we go. Okay, we are starting with chapter 2 in the textbook. You guys don't have your textbook yet, hey? Okay, that's fine. Okay. No, cool. Right, I will just have to post the picture of the work either on the board or on Google Classroom, but we can sort that out. Okay, so chapter 2. Okay. As your notes obviously don't have to look exactly the same as mine. You can do your headings however you want, but the content, you want you to write all of the work down. And I will still get to know your name. Sorry, it's going to take some time with masks and so on, but I'll get there. Okay, now guys, the name of this chapter is Equations and Inequalities, but it actually focuses on quadratic equations. All right? Can anyone remember what a quadratic expression or equation looks like? What makes it quadratic? That word quadratic, what do you think of? Please? That's two answers, correct. All right, what do we see in the type of equation? What do we see in terms of exponents? We got an x to the 1, an x squared, an x to the 3, an x squared, right? Okay, so I'm just going to write here quadratic equations. Just put an x squared there above quadratic. That is how you identify that something is quadratic when the highest exponent of the variable. It can actually be any letter, right? Any variable. Usually we just work with x. Okay, if the highest exponent of the x or the a or the b or whatever variable we're working with is 2, we call it a quadratic equation. Can be solved in 3 ways. At the moment, you guys know one way of solving a quadratic equation. All right, I'm going to teach you 2 other ways. So the first way would be by factorizing. Which we are going to do examples of just now. And this is what you did. I think you did it in grade 9 actually for the first time when you learned how to factorize, for example, a difference of 2 squares. Does that sound familiar? Like an x squared minus 4. All right, x squared minus 4 is a quadratic. All right, and if they then made that equal to 0, you have to factorize and solve. So don't worry, we'll do examples now. Okay, so that is the first method. The second one is something new. You won't know what I'm talking about now, so we'll just write it down for now. We'll do this tomorrow. Is by completing the square. Don't panic. I will show you how to do this. And then the third method is by using the quadratic formula, which you also don't know what that is yet. We will get to that on Friday, probably. So this, put on the slide here. This is in grades 9 and 10. We use 2 only. Okay, now I'm just going to make a heading for factorizing, and we're going to revise that. Okay, now guys, factorizing. Yeah, we learn it in grade 9 and usually something that a lot of people struggle with because it's a completely new way of thinking about terms and so on. But the purpose of factorizing is actually to go from multiple terms to one term. Right, that's always what you are trying to do in your factorizing. You'll see now in the example. You go from multiple terms to one term. So let's do some examples where we are just going to factorize. Okay, we're not actually going to be solving any equations yet, we're just going to factorize. So the first one, if they ask you to do 9x squared plus 3x. Right, they want us to factorize that. So how many terms do I have? 9x squared plus 3x. Two terms, right? So we remember that pluses and minuses separate them. Okay, so 9x squared is one term and positive 3x is the next term. So we have two terms here. So now, once we factorize, or after we factorize, we want to have only one term. Okay, and another thing that we can add here is that factorizing is the opposite of multiplying out. Opposite of multiplying out. Okay, good. Now guys, if you're thinking of multiplying, what is the opposite operation of multiplication? Division, right? So factorizing is actually division. Right, so I'm sure you guys can remember this kind of factorizing. It's not that bad to do this one. We need to look for a common factor, right? Something that can, we normally say that can go into each term, but actually the correct mathematical terminology is something that can divide into both of them, right? That is what makes something a common factor, when it can divide into both of these terms. So we start with the numbers. We have 9 and 3. Which number can go into both 9 and 3? 3. Now, I used the wrong words, hey? Which number can divide into 9 and 3? 3, right? So 3 is a part of our common factor. So we put the 3 down. We might have another part of the common factor, we might not. Okay, now we look at x squared and x. What can divide into both x squared and x? X, good. So the common factor is x. Because you can say x squared divided by x and get an answer, and you can say x divided by x. All right? So x can divide into both of those. So that's my final, my final common factor. Is there anything else? 3x, that's it, right? Now we put a bracket there. And now to get whatever must go into the bracket, we have to divide each original term by the common factor. Okay, so we're now going to say 9x squared divided by 3x. What's 9 divided by 3? 3, and x squared divided by x? X. So 3x. Plus, the next term is positive, so it's going to be positive in the bracket as well. Now, what is 3x divided by 3x? 1, good. Plus 1 must go into that bracket. Now we've divided both terms by the common factors, and now we can close our bracket. Do you notice that I now only have one term? Right? Because here I have 3x multiplied by, and multiplication doesn't separate both terms. Okay, and multiplied by a bracket, which is also just one term. So we've gone from two terms to one term. But another thing that we must just check is that whenever you are done factorizing, the number of terms in the bracket has to be the same as the number that you start with. Okay, so do we see that we start with 2 terms, and inside the bracket, if we ignore everything else, we have 2 terms again. Okay, so just make a note of that, please. Okay, now I don't know if you have space on the side. If you do, you can write it on the side. If you don't, you can just write it underneath. Now I'm going to change this question slightly, and I'm going to say, solve for x. I'm going to do the same equation, the same expression rather, but I'm going to turn it into an equation by making it equal to. Now I want you guys to notice, if we haven't done this before, right? If you're just looking at this equation, firstly, do we all notice that this is an equation? So it's equal to 0. Okay, these two things are different. This is an expression, right? It's not equal to anything. This is an equation. It's equal to 0. Okay, if they just give you an expression, guys, if there's no equal to anything, they can't now ask you to solve for it. Right, it's a very common error, and we will talk about it so many times. People keep making this mistake. Often in case of exams, you see something like this, you're like, okay, I'm factorized, then you just want to make it equal to 0 and solve. Even though that's not even what the question is. All right, you can only solve for variables that find the value of a variable if it's actually an equation. They're giving you an equation. Okay. So these two are similar, but they are different. This is an expression and this is an equation. Now, what you must remember is when you are solving a quadratic equation, firstly, how do I know that this is quadratic? This is an x squared. Okay, shall we highlight that? Highlight that x squared thing. And this might sound now, but let's see, there we go. X squared, so this is a quadratic equation. Now we'll write down the switch now after we done this example. When you see that you have a quadratic equation, you have to, and you might remember this from last year, you have to make sure that everything is on the one side and it's equal to 0 on the other side. Do you remember that? Does that ring a bell from when we did quadratic equations? Everything on the one side equal to 0. Okay, that is very important. You can't actually solve this equation if that is not. Okay, so we have all our terms and they're equal to 0. Next up, you're going to factorize. Okay, so first step, with everything on one side equal to 0, we will write it down just now. Next step is to factorize, but we've already done the factorization here on this side. Okay, we've already done that, so we can just rewrite that. So when we factorize this, we get 3x times 3x plus 1 equal to 0. The actual factorizing doesn't change because it's an equation. All right, I'm still factorizing the same way. Still look for common factor. We write the common factor down. We divide each term by the common factor. The only difference is now that it's equal to 0. Now you might remember this from last year, you might not, but when you have a product of two things, can we agree that that is what we have here now? We have 3x times a bracket. Right? Do you see that we have two things here, two factors that we are multiplying together? And the answer that we get when we multiply these two together is 0. Right? Do you understand that that is what's written here? This is saying something multiplied by something else is equal to 0. And that's the only way for you to get 0 as an answer when you're multiplying two things together, is if one of those things is equal to 0. Think about that. I'll say it again a couple of times. The only way to get 0 as an answer when multiplying two things together is if the first thing is equal to 0 or the second thing is equal to 0. Right? Think about it. If you have 0 times 2, what's the answer? 0 times 2 is 0. If you have x times 0, what's the answer? 0. Anything multiplied by 0 is 0. Okay? I'm going to say this again now. The only way to get 0 as an answer when you are multiplying two things together is if the first one is equal to 0 or the second one, which is a bracket in this case, is equal to 0. Okay? So if our first part of this product, if 3x is equal to 0, right? Say that's true. Say 3x is equal to 0, then what am I going to have here? 0 times the bracket. And what is 0 times any bracket? It doesn't even matter what's in the bracket. 0 times the bracket is always 0. So if that first part, 3x, if that is equal to 0, then that will work, right? Because then if I multiply these two together, 0 multiplied by anything will give me an answer of 0. Okay, but that's not the only thing that will work. So now you have to write the word forward. I can also have 3x multiplied by 0 here. That will also give me an answer of 0, right? If the second part of my product here is equal to 0. So if 3x plus 1 is equal to 0, then the answer will still be 0, right? If I say 3x times a bracket, sorry, if I say 3x times 0, this whole bracket, then my answer will be 0. Right? Does that make sense? So that is actually what you always use, guys, when you have a quadratic equation and you factorize it and you're ending up with two parts. Right? You'll always have two parts when you're factorizing. It's either a 3x on its own, like here, and a bracket, or normally it's two brackets. Okay, that might seem a bit more familiar. Okay, we'll do an example like that just now. You always end up with two factors, two things that make up your product equal to 0. Then you make the first part equal to 0 or the second part equal to 0. Okay, again, because the only way to get 0 as an answer, like you have here, when you are multiplying two things together, is if one or the other is equal to 0. Okay, but guys, can I solve for x? Not yet, okay? I need to do some more work. 3x is equal to 0. Okay, now let's just think of, because now this is not a quadratic equation. This is actually a linear equation, right? Now, if I look at what I calculate here, I have 3 times x. To get rid of that 3, what is the opposite of multiplying by 3? Dividing by 3. So on the other side, I have to now divide by 3. What is 0 divided by 3? It's 0, okay? So for this, the answer for x is 0. For that first part, we're dividing by 3. But remember, 0 divided by anything is just 0. Okay, so that's why that fixed value is 0. On this side, what am I going to do first? Am I going to get rid of the 3 or the plus 1 first? The plus 1. Hey, what's the opposite of adding 1? Minusing 1. So I'm going to have my 3x here equals, and what is 0 minus 1? Negative 1, hey? And now I'm going to divide by 3 to get rid of that 3 in the front. Okay, remember, what am I saying here? 3 times x. To get rid of the 3, I have to do the opposite operation. So I must divide by 3. Okay, so x is going to be negative 1 over 3. 1 divided by 3. 1 over 3. So that is what someone was saying earlier. When you have a quadratic equation, you end up with two answers. Okay, you see in this case, we got our two answers. All right. Okay, let's do another one here. Number 2, I'm just going to say x squared minus 4. Right, so I'm factorizing. Okay, so that's clear to you guys. First, I'm going to factorize, then we're going to solve the equation next to it. So see if you weren't able to put them next to each other for the first example, you can put it in for the next one. Okay, so we do the factorizing and the equation. x squared minus 4. Is there a common factor here? That can take off? No. All right. So what do we think? What kind of factorizing can I do there? Yes. Difference of 2 squared. Good. All right. Right. The word difference means that you're minusing. Okay. So you have to have a minus there in between the two terms. If this is x squared plus 4, we can't say that that's a difference of 2 squared. Okay. So just circle that minus. Difference of 2 squares. Some teachers call it dots. That's fine if you want to refer to it like that. DOTS. Difference of 2 squares. Okay, that's perfectly fine. Now, yes, it's different because there's a minus in between them, but also the two terms have to have square roots in order to be squared. Okay, so x squared is a square because the square root of x squared is x. Okay, and 4 is also a square because the square root of 4 is 2. Okay, so you have to make sure that you actually have that as well. Okay, now I hope you guys can remember this. When you have a difference of 2 squares, you're going to factorize into 2 brackets, right? So you can put your 2 brackets there so long. You're going to have the same terms in the 2 brackets with the one bracket is going to have a plus, the other one is going to have a minus. And how do we find the terms in the brackets? Can anyone remember? Yes? X plus 2, x minus 2, yes. How do we get the x? Square root, good. Okay, so your terms that go into these brackets are the square roots of the original terms. Okay, so the square root of x squared is x. So that goes into both of them. The square root of 4 is 2. And then you put a plus in the one and a minus in the other one. Okay. That's it. If they just ask you to factorize, that's your final answer. Okay. Notice it's not equal to anything here. We can't solve for x. They're just giving you an expression. They're asking you to factorize it. That is it. Please don't multiply it out again. Okay, then you're going backwards. Then you're going to lose mark. Okay, how many terms did we start with? 2. How many terms do I have now? 1. Okay, let's write that down. I'll try it here, otherwise I'm going to run out of space. 2 terms, and now I have 1 term. Remember, that's the purpose of that. Okay. But now, if they give us that same difference of 2 squares, and they now make it equal to 0. Now we can actually solve for x. Now we can actually find the values of x that will make this equation true. Notice, guys, it's an x squared, so it's a quadratic equation, meaning we're looking for 2 answers. Okay? The first step, sorry, I said we're going to write it down earlier, and I still haven't, but I will now after this one. The first step is to make sure that you have everything on the one side equal to 0. That is done. It's given like that. The next step is to factorize. Okay, we've already done the factorization here. So it will be x plus 2, x minus 2 equal to 0. You notice that again we ended up with the product of 2 things equal to 0. Just like we did in the previous question. In the previous question, we didn't have 2 brackets, but we had a trace and we had a bracket. Now we have a bracket multiplied by another bracket. So now we're going to say if the first part, the first bracket is equal to 0, then I'm going to have 0 times the bracket, which is equal to 0. So that will work. Or if my second bracket is equal to 0, x minus 2. Right? Then I'm going to have a bracket times 0, that's also equal to 0. Okay, so both of those will make my product equal to 0. Have I solved for x? No. So here, this plus 2, when I move it, it's going to become a negative 2. So we're going to say 0 minus 2 is negative 2, right? And for this one, x is equal to 0. What's the opposite of subtracting 2? Adding 2. Thank you. So we're going to say 0 plus 2. All right, which is just 2. There we have our 2 answers. That's the nice thing about an equation is that you can always check your answer. So if you're not sure if you did it correctly or not, just take your values that you got, put them in the original equation and see if it works. So if we have negative 2 squared, x squared, right? Negative 2 squared. What's negative 2 times negative 2? 4 minus 4 is 0. Let's see if it works for positive 2. 2 squared is 4 minus 4 is 0. Okay. We have 4 minutes. I'm just quickly going to write down the steps. To solve quadratic. Okay, step 1 would be get all terms on, I'm going to use LHS, left hand side, yes? Oh, what's your hand up? Did I imagine? Okay, get all terms on the left hand side and then equal to 0. Okay, does that make sense? You want everything here equal 0. Okay? Second step would be to factorize the left hand side. Then step 3 would be to make each factor equal to 0 and solve for it. So that's what we did in the last, well, kind of middle line here. The first factor was the bracket, the second factor was the second bracket. We made them both equal to 0, and then we solved in that new kind of equation. Okay. You will notice that I haven't even spoken about trinomials. Right? I have good news for you guys. After I teach you the quadratic formula, which is method number 3, you will never in your life again have to factorize a trinomial. So I'm not going to waste time on even doing that. Okay, so I will show you tomorrow how to use the quadratic formula to solve a trinomial equation. And then we're not going to spend time on that. All right. Okay, guys, I'm not giving you a conference today. How nice is that? Don't get used to it though. Just saying.